Alright, it's Benjamin from Learn Finance Free. I want to continue to discuss a tiny little detail, and let me show you. Okay, so previously we discussed about the F statistics when you are comparing the SSE of unrestricted model as well as SSE of restricted and see whether it's significant. Okay, and you depending on whether you reject the hypothesis, you say rejected. So all of the variable is zero, or rejected at least one of this is not zero. Okay, and yeah. So here comes your tricky part: is degree of freedom n minus k minus 1. So for example, you got the another table like this. We got a all sort of degree of freedom, and say this regression. Say we got a q. Yeah, let's say q. Okay, we got q regression, and we got k. Sorry, we got k regression. So variable, we got k variable here. We got residual, and residual will be how many? I don't know. The total we need to got total in order to get residual. The total is n minus 1. Okay, it's not n. So that's the reason residual equals to n minus k minus 1, because you use this, you get rid of k regression, degree of freedom, we got residual n minus k minus 1. Okay, so basically k minus k minus 1 will be the residual degree of freedom. So if you look back here, this will be the residual degree of freedom, df, degree of freedom. Okay. If you think about this, sum square of error, sum square error residual. Okay, remember, if you are talking about this, if you're calculating this, you should use this one, not this mean sum square. Okay, but rather use sum square. Mean means use this to divide this by the degree of freedom, right? So for example, we got sum square for regression, so sum square or regression sum of the square. Mean means regression sum of the square divided by k, right? And if you think about this, we got this sum square of residual, so sum square of error residual, and use the sum square of residual divided by n minus k minus 1, right? And then you add this up, this two add up, we equals to n minus 1. Okay, so that's the reason you use so for example, you got this unrestricted. So unrestricted, you're going to, let's plug in, okay, just quickly practice. Unrestricted, so you're using, so the ANOVA table will be just one model ANOVA table. So you may get one ANOVA table for restricted and one ANOVA table for unrestricted. So you have to use from different model, different models ANOVA table. Restricted, okay, SSE. So SS and E, so this one, okay, use that specific table of a restricted models SSE, plug it in, okay, use the unrestricted, so another ANOVA table, find another, say here is another one, you got this SSE, plug it in, okay, and subtract it, divided by Q. So remember, we got like a model 1, okay, so we get like a, I don't know, B0 plus B1 x1 plus b2 x2 plus epsilon. All right, so there will be a model 1, we got a model 2 of b0 plus b1 x1 plus b2 x2 plus say b3 x3. Okay, there's more variable here, and b4 x4 plus b5 x5. Okay, so we got like a 3, and we got the epsilon here, so we got 3 b 3 to 4. All right, so you find this specific model and this specific model's ANOVA table, ANOVA table. You find that and use this. And what we got 1, 2, 3, so this will be the Q, okay? So divided by Q, divided by 3, and use this unrestricted model. So which one is unrestricted? Quick quiz, come on. Unrestricted means that we got more, okay? So use this unrestricted model's SSE, so we find this SSE of a unrestricted model, and divided by the n minus k minus 1. N minus k minus 1 would be the residual degree of freedom here. Okay, so just to find that model's ANOVA table's residual degree of freedom, and plug it in, okay, then you can calculate the F statistics and compare that, use the some threshold, and you decide whether you reject it or not, okay? And thanks, don't forget to give me a thumb up, subscribe to my channel, okay? Thanks, bye.